Hello guys, welcome to our class today, and we're going to look at the last bit of states of matter, which is gases and their relationship with the mole. So we're going to look at relationship of gases with the mole. In mole, for gases, we use molar gas volume, MGV. This is the volume occupied by any gas at standard conditions, which are two: room temperature and pressure, RTP, and standard temperature and pressure, which is STP. I'm going to write it. So one mole of any gas, it can be hydrogen, it can be oxygen, it can be nitrogen, it can be carbon dioxide, it can be ammonia. At STP, standard temperature and pressure, occupies the following: 400 centimeter cubic. It can also occupy, which is the same as 22.4 liters, which is the same as 22.4 dm cubic. So any gas at STP occupies this volume, and STP is 0 degrees Celsius and 1 atmosphere. These are the conditions at STP. And again, one mole of any gas which I've listed above, there are many gases, at RTP. RTP is 25 degrees Celsius and 1 atmosphere, occupies 24,000 centimeter cubic, which is the same as 24 liters, which is the same as 24 dm cubic. This is the volume occupied by 1 mole of any gas at this standard condition. For example, I can write an example. 1 mole of carbon dioxide at STP will be 22.4 dm cubic, and the mass for 1 mole of carbon dioxide, carbon is 12, oxygen is 16 times 2, 32. 32 plus 12 is 44, which is 44 grams, and which are the Avogadro's number of particles, which is 6.023 times 10 power 23 molecules. So this is the relationship of moles. This is 1 mole occupies 22.4 at dm cubic at STP. It has a mass of 44 grams, and the molecules present are those. So for example, I have an example here. How many number of moles? How many number of moles are in 11.2 liters of CO2, carbon dioxide, at STP? What do you do? Just come and say 1 mole of any gas at STP occupies what? 1 mole of any gas at STP occupies 22.4 liters. What about 11.2 liters? What will it occupy? Because this is the volume that we have at STP. So we can calculate that and find the number of moles. It will be 11.2 times 1 over 22.4, which will give us 11.2 divided by 22.4. You get 0.5 moles of carbon dioxide in STP conditions. So let's go to our next question. Our next question goes: what is the number of moles of the following? How many moles are in the following? We have 16 grams of oxygen. 16 grams of oxygen, we can say, we can get the number of moles. oxygen is O2, molar mass will be 16 times 2. Because molar mass of one oxygen atom is 16 times 2, we get 32 grams per mole. So this is the molar mass of oxygen O2. Finding moles will be 16 grams, which is mass, divided by 32, which will be 0.5 moles. And one mole occupies 24,000 centimeter cubic. What about 1 mole at RTP occupies 0.5 moles? Pause. So 16 grams of oxygen, you find molar mass. O is equals to 16. O is given by, O is 16. So O is 16. So 16 times 2, we have 2, you get 32 grams per mole. And so finding moles is 16 divided by 32, which is molar mass. This mass that we had was 16. Molar mass is 32. Finding 0.5 moles. And 0.5 moles of oxygen are present in 16 grams of oxygen. So you ask yourself, what about 1 mole at RTP occupies 24,000? What about 0.5? Therefore, the answer will be 0.5 times 24,000. This is like half of 24,000, which is 12,000 centimeter cubic of oxygen. Let's go to ammonia. 1.7 grams of ammonia. 1.7 grams of ammonia. What will it contain? 1.7 grams of ammonia. How many number of mole volume? What is the volume? What is the volume of the following? 1.7 grams of ammonia. So finding moles is molar mass of ammonia. This is 14 plus 3, that is 17 grams per mole. So 17 grams per mole. Finding moles will be 1.7 divided by 17. 1.7 divided by 17, 1.7, because that is the mass that is present, divided by the molar mass, which is 17, you get 0.1 moles. This is mass over molar mass. Mass we had is 1.7 and molar mass of ammonia is 17, because nitrogen is 14 plus 1 times 3 is 17. You get 0.1 moles. But 1 mole of a gas at RTP is 24,000 centimeter cubic. What about 0.1 moles? What about 0.1 moles? You calculate 0.1 times 24,000 will be times 24,000. The answer will be 2,400 centimeter cubic of ammonia is present in 1.7 grams of ammonia. The last question. You burn 6 grams of carbon. Carbon is like charcoal in plenty of air. What volume of the gas will form at RTP? What volume of gas will form at RTP? So you first calculate the number of moles of carbon. So carbon molar mass is 12 grams per mole. Finding moles of carbon will be 6, which is mass, divided by 12. The answer will be 0.5 moles, because it's a half of it, of the molar mass. So 0.5 moles. 1 mole occupies at RTP 24,000 centimeter cubic. RTP is room temperature and pressure. Remember what we said above. So what about 0.5 moles? So it will be 0.5 times 24,000 centimeter cubic. The answer becomes 0.5 of 24,000 is 12,000 centimeter cubic. And this is because ratio of carbon to carbon 4 oxide is 1:1. That's why we use the stoichiometry relationship, because the number of moles in carbon will be the same as the number of moles in carbon 4 oxide. So it's ratio that has helped us find the number of moles of carbon 4 oxide, so that when we multiply the molar gas volume, you get 12,000 centimeter cubic of CO2 is produced. The last question, what volume of oxygen is used up? What volume of oxygen is used up? It will be the same. Why? Because the ratio of carbon to oxygen here is 1 to 1. And the number of moles of oxygen of carbon we found to be 0.5. Therefore, oxygen will be 0.5. Carbon 4 oxide will be also 0.5. They will be the same across. So therefore, the number of moles of oxygen is 0.5. Therefore, it is 1 mole will be 24,000. Same way, because the ratio is 1:1. What about, this is 1 mole, what about 0.5 moles? So you calculate that, 0.5 moles times 24,000 will be 12,000 centimeter cubic of oxygen. 12,000 centimeter cubic of oxygen. That is the volume of oxygen used in the reaction. So this is the relationship of solids, gases, and even solution. You can find a question asking about solution. So looking at this question, that is how we go on it. Thank you. Let's meet in our next class so that we can do relationship of both reactants to be solutions, gases, and solids. This has helped us to know on gases what to usually do. Thank you. Let's meet in our next.